So today we are going to start the combination of lens. Again, combination of thin lenses. So I'll go back to the old derivation of prism, just as a recap. So let's say we have prism, and now cut into two halves, and a ray of light is coming. And we know that it will deviate, right? So for a small angle prism A, the deviation is how much? It depends on the height h, and we call this as focal length f, because it's parallel beam. So deviation they have defined as h upon f, right? And we know that deviation was mu minus 1 into a. Understood? So for prism, we wrote deviation as this, but you can simply say that deviation is always height upon f. So even for although we are going to use for paraxel, but even for paraxel, the deviation will change as you go higher. And every lens is a collection of prism, if you remember. Understood? Every lens is a collection of prism. So whether the beam is coming parallel to the pencil axis or not, the deviation suffered by the light ray by a thin lens is always fixed. It is h by f, and it really doesn't matter whether it is hitting at angle or parallel to the pencil axis. It should be small enough. The angle should be small. Then we have the same form. So this is the first thing which we write for the lens, that if for a thin lens, so deviation we write like this. Just
Hello, sir. Hello.
Harshit, just give me 2 minutes. 2 minutes.
Oh, sorry.
Sorry, guys. So the first thing that we need to remember is that deviation is always the height at which you hit upon focal length of the lens. Now you may ask, so what will happen if I hit the like this? See, the answer is same. The deviation will be same. So now the angle from here will be delta 1. Okay. So angle we don't care. I mean, because of paraxial approximation, even the angle will be there. It will be almost next to 0, right? So these are small angle values or paraxial values. Is this clear?
Yes.
Now, what happens if you bring more than one lens into the path of a light? So let's say this is the first lens of focal length f1. So if a parallel beam of light is coming, what will happen to this light? It will bend and will meet
Yes.
somewhere here, let's say. But what if we bring another lens in the path? If you bring another lens in the path of the first, I mean, this ray, so it will actually create one more deviation. That is idea. So this is the first deviation, as you can understand that clearly. What is the first deviation? We call it delta 1. But the moment it will pass through the second lens, because I'm intercepting the path of the light ray before it reaches the focal, I mean, principal axis. So because the second lens is coming in the path of the light ray before it has actually met the principal axis, it will carry forward another deviation, but because it is hitting at a different height, the amount of deviation will change. And that is logical because if you pass through the optical center, there is no deviation. It means H0 delta 0. Correct? So when you hit at a height H2, as per the deviation rule, the new deviation suffered will be lesser. Understood? So this is the deviation number 2. It is clear?
Yes.
Are you getting the idea of deviation? Okay. And because this is deviating, so this distance, we have to understand every distance clearly. This distance, we are going to call as focal length of which lens? First or second?
Oh, second.
So this is distance is called f. Okay. And the gap between the two lenses, we call it small d. and the distance from the first lens to the expected point of convergence, which never happened in fact. This distance, what we can call? This distance is how much? If there is no second lens, where the light would have met?
Oh, F1.
F1. At the focal point of the first lens, isn't it?
Yes.
So the idea is, if you bring a two lens system, or in fact 3-4 lens system, the deviation will keep on getting added if all are converging. If first is converging, other is diverging, so the net deviation will decrease, right? Because the delta 1 will be clockwise, for example, then delta 2 becomes anti-clockwise because of the diverging nature of convex concave lens. Understood? Hello, hello.
Yes, sir.
So if all lenses are converging, then deviation will add up, isn't it?
If what?
If you add all deviation, if all lenses are converging, then the total deviation will be how much? Sum of all deviation.
Summation.
So the question is, can we replace this combination by a single lens, which can create the net deviation as the two together are created?
H will be same. So we can find focal length.
Yeah, it means I want to hit the light ray to some equivalent lens, and we need to understand where that lens should be. It is pretty easy to follow by
It will be
simple geometry.
H1 over F dash equals del 1 plus del 2.
Very good.
Can find.
So you can see if we extend the white light backward, this is the position at which that equivalent lens should be. Because then this is the net deviation. Do you realize this? This is delta 2, this is delta 2. And this is the total deviation, isn't it? From the external angle property. So from the external angle, what you can say, that delta equals to delta 1 plus delta 2. External angle is sum of the far two interior angles. If you look at the triangle A, let me B, C, D. So in the triangle AEC, can you see that the net deviation is equal to sum of the deviation?
Yes.
So the F1, F2, which are two lens, we can replace by the equivalent lens kept at this particular position, such that the light ray coming will exactly go to the F2. So this distance, which is interesting to understand, from this line, this distance we can call which, what you can call? This is called F equivalent. Do you realize this?
Yes.
Okay. So we start with this relation del equals to H1, del equals to del 1 plus del 2, and del we can write as H by F equality, isn't it? H1. Can you say? Because this is the height is also H1.
Yes.
So the del we can convert del as H1 by F equivalent.
Del 1 as?
Del, only del.
Del as H1 by F equal.
This understood? So what is del 1? It is H1 by F1.
H1 by F1.
What is del 2? H2 by F2.
H1 by F2.
H2 by F2. Del 2 is H2 by F2.
Oh, yeah, sorry. H2 by
Now the only problem is how to write H2 in terms of H1, because then only I can cancel the height, right? So for that, we can use a similar triangle. Let's call a point D here. A, B, C, D, E, F. So you can see the del 1 we can also write it as this upon D, right? because we have to make use of the D also. So in triangle AFC, can we write del 1 equals to FC upon D? Can we write tan theta,
Yes.
like the tan theta formula?
Yes.
And FC we can write as H1 minus H2. Okay. And H delta 1 is how much? H by F1, H1 by F1. So basically now you can write H1 minus H2 equals to D H1 by F1. So H2 is basically H1 minus D H1 by F1. So this is equation 2, this is equation 1. And now H2 by F2, if I want to replace, therefore H2 by F2 becomes H1 by F2 minus dH1 by F1 F2. Is this clear? Yes or no?
Yes.
So from 1 and 2, what you can get? So from 1 and 2, we can get but H2 by F2 we can replace by H1 by F2 minus dH1 by F1 F2, right? And therefore you can say H1 gets cancelled. So what you get is 1 by F equivalent is 1 by F1 plus understood.
Yes, sir.
So this is called the combination of lengths formula, and this formula is applicable or valid when the D is less than F1. It means before it will hit the light ray must hit the second lens before it hits the lensful axis. Understood?
Yes.
So this is how we derive. Okay. Now if I go back to the thin prism again for some reason, and if we have a light ray, deviation is how much? H by F. Obviously, deviation is that one. Okay, deviation we write as mu minus 1 into A. This we write for A, right? But what if the surrounding is having some medium? So in that case, the delta in the medium will be mu by mu medium into 1 into A. Okay. So just Okay. Okay, actually, I just wanted to show you that the deviation in a medium will change. If the prism is kept in a medium, then deviation will follow a different formula. A mu term will appear in the denominator. So this is not the exact thing I was looking for, but this is just to get an idea that okay, if the lens is kept in a medium, then things will change. So there is a question that what if the space between the lens is filled with some medium? I think this is not required. I can just put a bracket. I can say ignore. So what if we have a medium and the medium is only between the lens So the problem is here we cannot apply the formula. I mean, so let's try to find the formula here. I mean, the derivation I haven't done before, but I was thinking of doing the derivation. If I extend this backwards, okay, this is one. Okay, so first deviation, this is the total deviation, this is the second deviation, this is also second by opposite angle property, and this is T. Okay. things will change. Can we derive the formula? This formula is given directly, but I want to derive that formula for the first time. If it is medium on one side, if there is no medium on the other side, how the formula will look like? Okay. Anyway, let me solve this question. I'll take method of interface. First, we'll write the image due to the first medium. So F1 we can write as R upon 2 times mu length minus 1. So mu length minus 1 upon R is F1 by 2. And now we can write the V. Okay, first V is we know. That is D equivalent F1. This is F1. This is F1. This is F2. So far, so good. So first is fine. Okay. But we cannot apply the formula. Okay. Okay. Anyway. So for the first refraction for the first surface, what we can add? Refraction at the first surface will be, if I make it 1, 2. So mu2, mu length by V1 minus mu medium, sorry, mu length, air actually. mu1 by u, which is infinity minus infinity. Equals to mu2 minus mu1 plus half. And for second surface, we can write as mu by F2 minus mu V1 equals to mu. If I add these two, this will cancel out. Mu by F2 equals to mu2 which is coming this is a very tough formula to derive. Leave it. Okay, we'll derive in my free time. It is something interesting. Okay, anyway, what you can remember is when the medium is filled with some liquid, then the 1 by F equivalent formula will change. It becomes 1 by F1 plus 1 by F2 minus D upon mu F1. This is the formula given in Eurodov actually. I thought of deriving it, but I'll derive it in some time whenever I'm free. So for a medium filled between the lengths, we can use the formula directly. But there's no need to mark up the formula. You can always derive further. So separation wise question will not come. What will come is the contact length. So what is contact length? If the D becomes 0. So because we have the formula 1 by F equivalent is 1 by F1 plus. So if D becomes 0, that is called when lenses are in contact, the equivalent focal length we can write as okay. Inverse of focal length of a lens is called power of lens. And power of a lens is the ability to bend, which is like a deviation. That therefore, the power gets added for any combination of lens in contact, and provided every lens is a thin lens. This is called power formula. Okay, I'll just write separately where P represents power of thin lens in air, assuming it is in air. So power of a lens is defined as 1 by focal length. And what it represents is the ability to bend. So when I say more power, it means it is capable of bending more. And we represent it is measured in diopter. It is measured in diopter or simply D in short. So when you express the focal length in meter, then power is called diopter. If you want to express in centimeter, we write 100 here and then this is fine. So for centimeter, you have to just write 100 in the numerator, it's done. And these all are formula for power of a lens in air. For power of a lens in a medium, for power of lens in medium, we write power of lens equals to mu of medium upon f of lens. And when the lens is completely submerged in a medium, then only use it. If it is one side and other side, we don't use it. So it is like a completely submerged part. And we know that 1 by FL from lens, okay, we can say from lens maker formula. Focal length of lens we write as mu m by mu L by mu medium minus 1 into 1 by R1. So P of lens we can attach mu medium upon FL, which will give you mu L minus mu medium 1 by R1 minus 1 by R2. So this is the exact formula, but if you look at most of the textbook, they write the wrong formula. This is from Irodov actually. So this is the formula for the focal length. Sorry, for the lens. So for air, mu medium is 1, and that is why you get the formula PL equals to and that is why the power of a lens in air is 1 by f air. So we generally write the air equivalent of focal length, not the medium. And the combination of lengths follows the air formula, assuming everything is kept in air independently and you're bringing them in contact. Okay. So from combination of power, what you can say, for any thin lens, any number of thin lenses in contact, so where all PIs are measured in air. Now, power is not only related to lens, it is also for the mirror, because power is all about bending property, how much you bend or deviate, and mirror can also bend. So, power of a mirror. So, for power of mirror, the answer is minus 1 by f. You may ask why minus? So, there's a thumb rule, the converging property, if a optical system is converging in nature, it must have positive power. Or you can say this is like convention. So all converging system will have positive power and all diverging system will have negative power. And we know that for converging mirror, the concave is the converging, the focal length is negative. And because the focal length is negative, so by putting minus n, we make it positive value. So as a thumb rule, you can remember that converging system will have positive power and diverging system will have negative power, no matter whether it is lens or mirror. All converging system together must have converging positive power. So if you are solving a question and if the net power turns out to be positive, it means the system is converging. And if the net power turns out to be negative, it means system is diverging. Okay. So this is a small thing for plane mirror, which is very special. And because for mirror, we know that focal length is r by 2. You can also write 2 by r. And because the power of the mirror does not depend on the refractive index, so it is same in every medium. So whether a mirror is in water or in kerosene or in air, the power remains same. For plane mirror, R is how much? So power of a plane mirror is 0. Okay. So we say that the plane mirror will not deviate the light ray. Or deviate means basically it will not converge or diverge. So what does it mean is a parallel beam of light will remain parallel. So deflection from the path is not power. Power is ability to either converge the beam or diverge the beam. That is whole idea. So if we have a parallel beam of light coming here, if I draw by two lines, even after reflection, it will remain parallel. So you can see the beam as such has neither converged nor diverged. Understood? Okay, so because of the ability of the plane mirror is neither to converge nor to diverge, it only deflects. So we say power is zero. So there are two types of power: converging power and diverging. So we can add for converging system. So for diverging system, power will be negative. So just remember this fact: converging and diverging. Okay. So what kind of question you can expect? So given any number of lanes of mirror, you can always find the equivalent. So let's say if we have so let's say we have just one lens, which is which lens is this? Can you tell me the lens? Okay. So now let's say we have a lens which is now silvered from one of the surface. Now silvering means the back surface will act as a mirror, correct? And now in front of such combination or such system, you put some object and you expect the image. The first question to you is, this entire system will act as lens or mirror?
Mirror.
Mirror, because the light cannot go on the right side, right? So light has to come
Yes.
back eventually, isn't it?
Yes.
So this entire system will act as a mirror at the end of this. Now we can have three surface, R1, R2, and the R2, I mean the surface of the mirror which is coinciding with the surface of the lens. Therefore, R2 for the mirror is same as R2 for the lens. Therefore, what is the focal length of mirror? Focal length of mirror will be, tell me guys. For mirror, the focal length is fixed now. For mirror, the focal length is how much? R by 2, right?
R
So
by
this
2.
becomes R2 by 2. Is this clear?
Yes.
So the power of the mirror will be
2 by R.
minus 1 by Fm.
Minus 2 by R.
And because it is converging, so this will become 2 by R2 if it is value. If R2 is a value, then I'll just write like this. Why positive? See, either you write the proper sign convention. If you remember that focal length of a mirror, we write as minus F, right? Concave mirror. So for concave mirror, the F is plus or minus?
For concave.
Mirror, the focal length
Negative.
is negative.
Negative.
So if you put minus of some value, what you get? Positive answer, no?
Yes.
So concave mirror is a converging system, and for any converging system, power is positive. In case of doubt, think this way, or else you just substitute things accordingly, you get the right answer. So you can leave like this. So you can write PM equals to minus 1 by 2 by Rm, and substitute the R with proper sign, you get the right answer. Understood? So when you're substituting the value, do it with proper sign. So convex mirror is which mirror? Converging or diverging?
Convex mirror is
Converging or diverging?
divergent.
So it will have negative power. And that is also obvious from the formula. For convex mirror, the focal length is positive or the R is positive, isn't it? If you have a convex mirror, so light will come from this side. And we have the center this side. So the focal length will be on the right side, which is positive. So because the focal length is positive, power will be negative. And so for any diverging system, the power must be negative. Understood? For any diverging system, power is negative. Is this clear? Yes or no? Hello?
Yes.
Is this clear?
Yes.
Okay. Now the question is how to solve question when we have silvering of lens. So we don't solve for every surface, and there are 3 steps. So the typical way of solving will be refraction from first surface, refraction from second surface, a reflection from mirror, then again a reflection from this second surface, and then a reflection from the first surface, and then final image. Why? Because the light ray will travel, will hit the first surface, will have some refraction, will refract from the second surface, will hit the mirror, and then will come back, and then will come back. So after how many refraction and how many reflection it will come to form the image. You can see that the light will cross the lens how many times? 2 times, isn't
Yes.
it?
Yes.
So light will enter the surface and exit both surface, and it will suffer reflection due to mirror how many times?
One time.
1 time. Therefore, the lens will get a chance to deviate the light ray how many times?
3.
The lens. How many times it deviate? A single lens will deviate once you cross it, right? So how many deviation you can see for due to the lens? Only lens, not the mirror. Okay, not getting it.
No, sir.
The light will enter and exit the lens. So how many times you cross the lens?
2 times.
2 times. Now the light is not aware that while coming back it is the same lens or different lens. For light it is the lens, and for lens it is the light. And as many times as we receive the light, I will create the deviation or bending. As a result, when the same light ray will go through the same lens twice, it will exhibit the converging behavior 2 times, and therefore the total power, or you can say total deviation suffered by the light ray will be twice of the value of power. Okay, understood? So you can say that the lens will offer twice the power, and how many times the mirror will offer the power? Mirror. Okay, I think none of you are getting it.
1 time.
1 time. See, power means bending, and bending means when you cross the lens, you bend. That's it. So for light ray, the bending will continue if you keep on passing through the same lens even 1,000 times. So for a light, it is 1,000 lens. For you, it is one lens. Do you realize what I'm saying?
Yes.
So technically, it is not one lens. It is how many lenses?
2.
Imagine I create a hypothetical scenario. In this hypothetical scenario, I take a lens and I paint everywhere except few parts. So a small part is like a hole is left for light to enter, and a small hole is left to light to exit. And the rest part is like a mirror. So these are reflecting surface. A light ray enters, reflects, 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 one reflects, reflects. So how many lens we should count if we consider this light ray? This is not one lens. How many lens we can call? In for the context of light ray, how many lens we have? Tell me. The lens
2.
is meant for light ray. So when you cross the once, it is only one lens. But when you cross the same medium 2 times, it is two lens. So how many
So
times
2
this light
times.
is?
2.
Two. Think again.
So lens means it will deviate the light ray.
So
And while entering
how many times
first
the
time,
deviation is happening?
first deviation will happen when the light will enter the first time. The last deviation, the light will exit.
Every time it is bending, there is a deviation by the light.
That will also. 12.
No, no. How many times you cross? Because before you meet the mirror, you go out of the lens by a small nanometer ahead.
So what is the answer?
The answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 lens.
Sir, but when the light will enter, it will deviate. Then
No, no.
12.
See, one crossing is one deviation, right? So the moment you enter, you have already deviated. When you go on the other side and come back, again you will deviate. So how you remember this? I mean, if you remember the basic one, this is called one deviation, huh? Or do we call this deviation this deviation? Do we count two deviation or one deviation?
1.
So for two refraction, one deviation, isn't it? Which means how many times you cross the lens is the number of deviation. How many times you cross the lens is called deviation. Do you realize this? Can you see how many lines you're crossing the lens? You can count.
11.
That is the number of deviation it will suffer. So this is for light. This is 11 lenses actually. So power of this system will be how much? 11 power of lens which you have taken. And how many reflection we can see here? Can you count the reflection?
10. 10.
So it is the 10 times power of the mirror. Assuming both mirrors are same. Understood?
Yes. In
So
the
if I
above
make
case, then it's one power of mirror and
2 power of lens. So for above the system, the P equivalent is 2 of lens and 1 of mirror. Understood?
yes,
So that is the idea. Is this clear?
yes, sir, understood.
Okay. So to solve question, let's say if I want to solve question, first of all, I'll find the power of lens, which we can write as mu minus 1 by R1. We write up with value. So R1 is negative minus, so if light is coming from left, 1 by minus R1 minus 1 by minus R2. So here R2 will be less actually. 1 R2 is more. So this will always give you positive value. And the power of mirror we can attach. It's a convergence system. So value wise we can attach. Is this clear?
Yes,
And now you can say P equivalent is how much? And after doing all these things, what you can replace is this is actually minus 1 by F equivalent. Why minus? You can ask why minus? Because why minus? Because the overall system will act as a mirror, correct? And power of a mirror is minus 1 by F. Is this clear? Is this clear? Tell me.
yes, sir.
Okay. So how to solve question is you first find the F equivalent, and once you have the answer, the next step is simple. Use the mirror formula. Why? Because you got the equivalent mirror. So 1 by U plus 1 by V is 1 by F equivalent. Equivalent is 1 by U plus 1 by V. It's minus P. And the U will be given to you. Like here, the U will be given to you. You can easily find V just using the formula. Understood?
Yes,
Okay, let me solve some question. You have AC Verma?
yes, sir.
Maybe.
So,
Yes.
sir, maths lecture is from 6:15. I have to charge 20 bucks.
Oh, okay. Math lecture was cancelled na, today? Hmm?
Chemistry lecture is cancelled.
Math is from 6. Ah. Okay, fine. So, as a whole, this is the end of the world. Nothing more is left. Just anyway. Okay. So we'll continue the next lecture if something left. So what is left is the defects of vision and of the consumer. So this will end all types of questions. You can solve any question now. Try it out, and I'll give some more examples in the next lecture.
Yes.